This week on Cloud Slaw, we're going to learn how to shoot ourselves in the other foot. In our last lab, we learned about S3 ACLs, ACLs, otherwise known as access control lists, and how risky they can be. The fact that ACLs use XML and not JSON is a major clue as to how old they are, but I think we still have them because the tech is baked deep into S3, and there's still a ton of older buckets that use them. I've personally released a ton of public content via S3, and it's only been recently that I finally realized I should stop being a bad example and stop using those ACLs and use bucket policies instead. And that's what we're going to focus on today, bucket policies, which are the resource-based policies for Amazon S3. Now, as a reminder, the three main policy types in AWS are organizations-based policies, or service control policies, identity-based policies, which we manage in IAM, and resource-based policies. And those are in a lot of different places, depending on the different kind of service they are, but the one we'll talk about today is called bucket policies. An easy way to remember how these interact is to understand their scope, which is what they apply to. Identity-based policies apply to identities, including IAM users and roles and other principals in our account. Organizations-based policies apply to AWS accounts, but they're set at either the organizational unit level or on the individual account level. Now, resource-based policies apply to resources that can potentially be accessed by things that live outside of your account. Now, this can be a bunch of different things, from an identity in another AWS account or from an IP address, some other attribute or origin that wants to access something that you are exposing from within your account. As a reminder, we need resource policies because there are real needs to share some resources outside of our account, but still control access. These identities, these origins, they don't live in our account, so we can't manage them with an IAM policy, and a service control policy would be even messier. All of these different policy types interact, as I previously documented in some earlier labs, and access is only allowed if there is an allow rule in the policies and there are no deny statements that block access. Now, normally you need an allow policy in every policy type for access. In other words, you have to have an allow in both your service control policy and your IAM policy for an action to actually take. But with resource policies, if the resource policy allows access and there's no explicit deny statements in any other kinds of policies, someone might get access without all of the policy types being checked. Let's go ahead over to our whiteboard. I can show you what this looks like. This is a diagram from AWS that shows the order policies are evaluated in. It's called the policy evaluation logic, and they keep it maintained up on their website. So this one is good to clip and keep for future reference because I do use it a fair bit. And as you can see, for any IAM call or API call or any kind of access, the decision starts up at the top there, and apologies for it being a little bit blurry. And then it goes through this framework with the yes or no decisions. Now, the highlighted section over here, that's also highlighted up on the link on the blog post, basically you'll notice that the first thing that's checked is there a service control policy? And that will basically mean, is this action allowed at all in this account? So that's the top level action. And if that action is allowed, then it's going to check, does the resource have a resource policy? And does that allow access? And if that does allow access, then that's the end and the person gets access. You'll notice that you don't have to have what's known as an explicit allow statement in any of these other policy types. The first important point to notice with that diagram is that every policy is checked for any deny statement. So that happens no matter what. So if you have a deny action in place, that resource-based policy is not going to skip that deny. But if you don't have an explicit allow, something that says exactly allow S3 get object, then you normally would have what's known as an implicit deny. Remember, all IAM policies in AWS and all service control policies, as we have seen in previous labs, have an implicit deny. They are default deny, and you have to have allow statements to go ahead and allow actions. But this isn't true with resource-based policies or the interaction with the resource-based policy. With a resource-based policy, if that has an allow statement, it doesn't worry about any implicit denies. It doesn't worry about checking the other policy types to see if there's also an allow statement. And that's because it kind of makes sense that you might need to do things this way, because you wouldn't have to want to give every user all through your account access to a specific S3 bucket. You just don't deny them access, and then you can control it with the resource-based policy. I hope that makes sense. The practical application of this all is if you give a role access to a bucket in the bucket policy, that resource-based policy, unless there's a deny statement someplace else, they're going to get access, even if that role doesn't have access to the S3 APIs in its own IAM policy. And while we're using S3 today, this is going to be the same with all of the different resource-based policies. If that gets a little bit confusing, you can kind of go over to the blog post, check it out. I describe almost using the exact same words, hello teleprompter, but it'll give you a little chance to read through it again. But that's that key piece, is that as long as you're not denying them access someplace else in some other policy, if access is allowed in the resource policy, they get access, and that's not the normal behavior for our other kinds of organizations and identity-based policies. All right, so let's learn a bit about the bucket policies themselves. And S3 bucket policies are JSON documents that define the fine-grained access controls for the Amazon S3 buckets and for the objects between them. These policies use the IAM policy language. They can be up to 20K in size. And the bucket policy has one or more statements, each defining who can do what under which conditions. It really does just look the same as the IAM policies with some slight differences in there. Now, what makes bucket policies really powerful is their flexibility to control access on a lot of different kinds of conditions to a lot of different kinds of principals, users, roles, other AWS services, and that complexity is how we get ourselves in trouble. Let's go over to the whiteboard, and here's an example of a bucket policy showing different options and highlighting some of the complexity. There's a lot going on in this bucket policy, so I'm going to kind of zoom in and out and show you some of the different segments and do some annotations. And the idea is just to give you a sense of some of the complexity of these. So for example, this is a pretty simple allow statement. So it's going to go ahead and allow access, and it's going to allow just that IAM role access to actually go ahead and see the bucket and list the objects in the bucket, and just for that one bucket. And that's the thing about resource-based policies. You do need to still have, even though it's being tied to this one particular resource, you still need to specify that resource in the policy. Now, just so you know, you can't like specify a resource that is in a different location. It has to be the one that's in there. And then here's another use of a resource-based policy. You'll notice that it applies to a lot of the different kind of API calls. So in this case, it's basically turning off, denying everything unless it's being done over secure transport. So that's SSL. So if secure transport isn't in place, that's going to go ahead. If it's not using SSL, TLS, as we still call it SSL sometimes, but if it's not an encrypted connection and a standard web encrypted connection, nothing fancy, it's going to go ahead and block any actions. And here's some other examples. So we've got one for cross-account access. How do you know that's different? All it is it's allowing anything in another account access to S3, this S3 bucket. That is some unfortunate use of the term root. We've talked about that before, but you notice the account ID there is different than the account ID up at the top where we're doing our role access kind of thingy. And then there's another example of restricting to only particular IP addresses. Okay, that all makes sense, and gives you a sense of just some of what you can do with the bucket policy. You can share across accounts, you can share based on IP addresses, but what does it look like to actually make something public in a bucket policy? And there's actually a couple of different ways, and that's what makes this a little bit confusing. Going back over to our diagram here, and I'll keep it a little bit zoomed in. So here's a couple of different options for making something public. So the first one is allowing access. So allow any principal to pull any object from this resource. So as you might imagine, that's not going to put any limits on something. So this is an allow, kind of an allow everything. Another option is to use, actually, I'll skip over that second one, but the one that I care more about is right here. And this is the one that I most commonly use. And it's the one that I'm using for all of our current cloud saws, because this says allow any principal access to get any object from this bucket if one of these conditions that we have previously looked at a little bit, it comes from any IP address. And that's that magic 0.0.0.0/0. CIDR range is, that means allow access from pretty much anywhere. So these are the two simplest ways to screw things up, but there's a few more out there. But hey, I got to start showing you how to poke yourself in one eye with your scissors at a time. And then we'll get more into like the lasers and angle grinders and maniacal clowns with pencil smashing your head down later ways of poking your eyes out. And look, one final reminder, I'm teaching you how to make things public so you know what to look for and what not to do. You should find a lot less of those ACLs that we saw last week, but I definitely see those myself still when I go and do assessments. But these bucket policies opening up to the internet, I do see quite a bit. And so you need to be able to recognize these when you operate in environments outside of your complete control. Now, in upcoming labs, we are going to show you how to find, fix, and block public access and do it without pissing everybody off in your organization. So kind of the intelligent way to go about doing that. But I wanted to show you what it actually looks like, what the actual error looks like, what the misconfiguration looks like first. Okay. With that, a little bit of summary. Remember that in Amazon, we have resource-based policies. And it's important to understand the policy evaluation logic, because if you allow access into resource-based policies, unless you explicitly deny access, anyone in your account can potentially, or who's authorized, can potentially get access. So you don't have to have an explicit allow. You just have to not have an explicit deny. Oh gosh, those double negatives again. And then there's a lot of different ways to make things public. You can make things public through other AWS accounts. You can make things public by specifying the IP addresses. All right, with that, let's get into the labs. Let's make some stuff public and let's see what happens. The actual mechanics of this lab are pretty quick. We're going to go ahead and create a new bucket. And then this time we're going to make it public with a bucket policy. And as I mentioned, we're going to use these public buckets later to learn more about detecting, fixing, or finding, fixing, and then preventing future public buckets when you don't want them. All right, as always, let's start in our sign-in portal. Within the sign-in portal, let's go to test account 1 and administrator access. And this process is really very similar to last week. In some ways, it's a little bit easier, although you have a little bit of text editing to do. Then click on S3, and we're going to go to create bucket. This time, we're going to stick with general purpose. We're going to use a little bit of a different name. So first initial, last name, dash S.L.A.W, and then dash BP, because this is going to be our bucket policy, and then dash some random, probably not totally random characters, but a little bit of keyboard mashing there just so we have a unique name. All right. Then leave things at ACL disabled. Remember last week we turned those on. This week we're leaving them off. We're going to do everything with the resource policy with that bucket policy. And check the box, uncheck the box that says block public access, and then check the box that says, yes, I know I am shooting myself in the foot. Okay, let's just say, what's my analogy this week? I'm poking my eye out with scissors. So, yep, I know I'm about to poke my eye out with scissors. Scroll down, click Create Bucket. This next part, then, you're going to want to go back over to the blog post, and you're going to copy out the JSON policy, and you'll see in a moment what that looks like. Grab the one from the lab section, not from the lesson, because the one in the lab is more detailed and will actually work. The one in the lesson part would error out. Okay, so I've clicked on my bucket. You see I have no objects in the bucket, so there's nothing to make public anyway. We're going to go to permissions, and in our permissions overview, we see that we have block public access is disabled, and we have our bucket policy. We'll go and click edit, and keep an eye out. You're going to need that ARN up at the top, But the first thing I want you to do is to paste in that generic, whoops, that's my actual bucket ARN. Let me grab that policy. And I paste in the policy. Now there's a few changes you need to make, and I'm going to walk you through a couple of the pieces of it. The first you'll notice is we have list bucket and get object. List bucket is like allowing you to see the directory contents, and then get object is what allows you to download any of those files. We want both of those in there. And just like we want both of those in there for making things as bad as possible, we have to have two resources. Why? Well, getting object, you need to have access to all the objects in the bucket, and that's what that little wildcard does. But you also need permissions just for the bucket itself to list the contents of the bucket, to list the bucket out. So that's why we have that. And you'll see that in both sections. What you want to do is copy your ARN and replace it, but be very important not to mess up any of the quote marks and to leave that slash and the wildcard where it's supposed to be. And you're going to do this 4 times. So paste it in there, and then scroll down. So this is what opens it up completely to like other AWS accounts. This is what opens up access via IP address. So anyone on the internet can look at your file contents, your bucket contents, and then they can download those. Paste and paste. Let me zoom back out. And if I click outside of it or scroll down a little bit, you'll see I should have no errors. So there's no red here. There's no red here. Let's make sure it all works. It says no errors down there, but we'll make sure. And we're going to go ahead and click Save Changes. All right. So at this point, we have this allowing anybody to get objects and list the bucket for just this bucket, as well as from the IP address. Now, if I put in a different bucket name, it's not going to work. Resource-based policies are tied to only the resource. The only thing I do if I change this to another bucket is generate errors. Now, one last note, and this is going to tie into what we're going to do in that next lab. If you go to buckets here, old school AWS people know that there used to be a column here that would tell you if it was public, and it did it with a nice little red warning label. They've changed that. We're going to learn how and why in an upcoming lab. And well, probably the next lab is the one we're going to address that. So I don't like that change because it was just much more obvious before when you were making those mistakes. Now you actually have to turn on another feature and utilize that to be able to get those warnings. And we're going to go ahead and do that. Then I'm going to show you how to do that at scale throughout your entire organization. Okay, quick and simple this week. Hope that worked out for you, and we'll see you soon when we learn how to find, fix, and block future public buckets.